Hello everyone. In this video, I will continue our series of methods of integration, and we will cover the basic logarithmic form. Previously, we learned that the general power rule for integrals is, so integral of un du is equal to, so you increase the power by 1 and divide with the new power plus a constant c where n should not be equals to -1. Because if n is equal to -1, this would cause the result to be undefined. So today we're going to discuss a case which gonna fill in the gap of when n is -1, and let's see what is the integral in that case when the power is -1. So when we did the derivatives, we obtained that the derivative of logarithmic function is 1 over x. So we're gonna use this, we're gonna reverse this process, and we're gonna come up with a formula for the integral. So let's set y is equal to ln x and take the derivative on both sides. So if you take the derivative on both sides, so this implies dy over dx is 1 over x. Since we want to find the corresponding integral formula, so we can rewrite this in the differential form, and at this step let's take integral on both sides. So when we take integral on both sides, so we found that integral of dy is y plus some constant, and integral of 1 over x dx we don't know yet. So from here we got integral of 1 over x dx is equal to y plus c. And we notice that in the beginning, so I'm just going to call it number 1. So using number 1 in the expression that we just obtained, we find that integral of 1 over x dx is equal to, so y is ln x plus c. So we just replace the value of y here. So y is ln x. So this is what we obtained, the corresponding integral formula. So in other words, we can say that when the power is -1, the integral is ln x plus c. So when the exponent of the expression being integrated is -1, the expression is a logarithmic form. Alright, so since we know that the logarithmic logarithms are only defined for the positive numbers, so we know that this is true for all positive numbers. But we need to also know what happens when x is not positive. So let's discuss that case when x is not positive. So when x is not positive, so let's start with when x is negative. So this implies negative x is positive. And from here, if I try to find the differential of this, so I also know that, so differential of negative x is negative of dx. So let's try to do the integral. So minus dx over negative x. In that case, we get ln of negative x plus c. Because remember, negative x is positive. So still we have positive inside the ln function. So still this makes sense. So I'm going to call my expressions here. So this is my number 1. This is my number 2. So combining 1 and 2, we get integral of 1 over x dx is equal to ln of absolute x plus c. So these two results can be combined into a single form using the absolute value of x. So ultimately, this is the formula that we're going to remember. Integral of 1 over x dx is equal to ln of absolute value of x plus c. So combining 1 and 2, we got this formula. So just a recap of few important things about this formula. This formula fills in the missing gap of the power n is equal to -1. So in power rule, we said that n cannot be equal to -1. But now if n is -1, so the formula for integral will be ln of the expression plus c. And another thing is, do not mix this formula with the integral of ln x. So we are discussing the integral of 1 over x. So if you find the integral of ln x dx, so that is equal to x times ln x minus x plus c. This we don't know how to drive yet because we haven't done the integration by parts. So in the coming lectures, you will know where does this formula comes from. So we will discuss it later. Next, let's try to generalize this formula and see what happens if we have some other expression in place of x. If you have another expression in place of x, so let's say we have u, where u is fx, so then the formula is 1 over u du is equal to ln of absolute u plus c. And the shortcut method which we're going to use, so we can just plug in the value of u. We can use the substitution rule. So let u is equal to fx. So we know that when we do the substitution, so 1 over fx. So this changes only the height of the function, right? And then we need to also change the width. So we need to find our du. So du would be, so let's just differentiate both sides first. So f prime x, and then from here du is f prime x dx, which is the differential of u. So differential of u is replaced by f prime x dx, and ln of, in place of u we have fx plus c. So this is the more generalized version of the formula that we're going to use in our question. So this is like the shortcut method. So if you analyze this function, so what we have, analyze this expression, what we have here is the reciprocal of the function. So we have reciprocal of the function and we have differential of the function along with it. So integral of this form would be ln of absolute value of the function plus c. So let's do a few examples in which we will use this result over and over. So first, so in this example, we have 1 over x plus 1 times dx, so integral of that. So we identify that here our function, so u is x plus 1 and differential of that is dx. So what we have is we have reciprocal of the expression x plus 1 and we have the differential of that expression. So it means using the logarithmic form, our answer should be ln of u plus 1, ln of x plus 1, plus c. Let's take a look at next one. So integral of cosine x over sine x dx. So again, in this one, we can use a substitution. So let u is equal to sine x. And if you find the differential of u, so you can take the derivative on both sides. So derivative of sine is cosine. and du is equal to cos x dx. So in this one, we again identify that we have 1 over sine x here in the denominator, and this is multiplied by cosine x dx. So we have a reciprocal of a function, and we have the differential of the function. So when we have this form, so integral is ln of the function, ln of the absolute value of the function plus c. If you are not so comfortable with this shortcut method, so you can of course write all the steps of the substitution method. So from here you could have done, so integral of 1 over, so sine x is u, cosine x dx is du. So from here you would have got ln of absolute value of u plus c, and in the end you just substitute back the value of u. So it's your personal choice. You can write all the steps, or you can just recognize the form and write your answer in one step. So one interesting formula that we get from this part 2 is that integral of, so cosine over sine is, what is that? So cotangent. So it means integral of cot x is equal to ln of sine x plus c. So we got a result for our trig functions. So integral of cot x is equal to ln of mod of sine x plus c. Let's take a look at the next one. So in next one, again, we notice that, so in the denominator we have 1 plus 3 e raised to power 4x, and in the numerator we have e raised to power 4x dx. So if we do the substitution, so let u is equal to this denominator, which is 1 plus 3 e raised to power 4x, and then we take the differential on both sides, or you can say that we take the derivative first. So derivative of 1 is 0 with respect to x. Similarly, the derivative of this would be e raised to power 4x would be e raised to power 4x. By chain rule, the derivative of 4x is 4. So we got du is equal to 12 e raised to power 4x times dx. So let's do the substitution here. So we notice that what we get 1 over u, and here we have e raised to power 4x dx. So if you want to write the value of e raised to power 4x dx, so from here we get du over 12 is equal to e raised to power 4x dx. Remember, we have to get rid of x's completely. So we have to get rid of our original variable when we do the substitution. So in this case, we get du over 12. So essentially we got, so 1 over 12 is just a constant outside. So you got 1 over u du. And this is our basic logarithmic form. So the answer would be ln of mod of u plus c, and you can plug back the value of u. So in this case, the u was 1 plus 3 e raised to power 4x. So this is what we substituted in the beginning, plus c. Actually, in this case, you will also notice that exponential function, so this value is always positive. 3 times of this expression will be positive. So whatever you have inside the ln, so that is positive. So you can simply write ln of 1 plus 3 e raised to power 4x plus c, because this expression is always positive. In case you are wondering how I could have done the same problem using the shortcut method without writing all these u's, without changing the variable. So I'll quickly show you that. So if I have to redo this problem using my shortcut method, so I would think in my mind that I have something like 1 plus 3 e raised to power 4x in the denominator, and I have e raised to power 4x dx here. So my expression in the denominator is 1 plus 3 e raised to power 4x, and if I have to take the differential of this expression, so differential would be, so differential of 1 is 0, differential of 3 e raised to power 4x would be e raised to power 4x times 4, so which is 12 e raised to power 4x. So here, if I have to make the differential of this expression, so I need to have a 12 here, so I'll multiply by 12 and I will divide by 12. So now when I do this, so I can see that I get the form, so reciprocal of an expression, so reciprocal of a function and the differential of the function. And I know that the derivative of this form would be ln of, so 1 over 12 is outside, ln of 1 plus 3 e raised to power 4x plus c, and again we know that this expression is always positive, so you can just remove the absolute sign and you can just rewrite this as ln of 1 plus 3 e raised to power 4x plus c. So this is how I would do this problem if I don't want to write all the substitutions. So I'll still give my reasoning that why I'm doing so, because I already recognized the form.